like on the bag tree when you pre-tin something, was the cadmium burn off on pre-tinning, you think, or?
Yeah, it
So it's safe, you can send them, customer end, you usually wouldn't have to worry about cadmium.
Oh, I'm sorry. The cadmium and zinc both fume a little, like water boils, but it fumes out, and they're both temperature suppressants. So that's part of the reason the reflow temperature is higher, but they fume out, which is dangerous, and but there's still quite a bit of cadmium left in it.
Oh, is there?
Yeah, so you don't get rid of the cadmium that way, and it's if they have to. Weyerhaeuser told the story once when I got started that they had a guy pre-tinning, and he had one window up above him, and this guy would pass out in the afternoon from the fumes. So what they do is they change operators at lunch. You see guys take a brazing station and they'll set up a fan and blow the fumes throughout the whole shop. You can get a new-tone fan, new-tone bathroom fan, and some dryer duct hose at a hardware store, a Sears, almost any place, and you can suck up a lot of fumes and blow them away with that kind of an operation. So.
We just think cadmium's bad though, flat out. If it smells sweet when you're brazing and you've got cadmium alloy, get the hell out of there, because it's just not good for you.
Oh yeah, cadmium's one of the very few proven carcinogens, not suspected, not associated with, absolutely proven. Yeah, we do use it. We've got permission to use it. We have the ventilation. We get checked for it, but a lot of customers just won't have anything to do with it. So, and I don't know what you're seeing, but in our industry, people are starting to appreciate the value of an experienced employee, that they really are a serious economic asset. And then Washington we have the toughest labor law, or toughest health and safety laws in the country behind California, so they're real proud of that too. So, but yeah. Well, the zinc is also a problem with it, and yeah.
Though it hasn't been out, so to speak, outlawed yet. And I just had a quick question on the reflow. When you pre-tin, even on the 56, you take a little bit of the zinc out of that alloy. So your reflows, do you put a temple stick on that, or do you look at that as being about 50 to 100 degrees higher than the original melt temperature?
We think maybe 30.
Okay.
We had a customer working with on. I told you what happened. We were pre-tinning some tips. A lot of them worked. We had 100,000 tips. A lot of them worked. Some didn't. We wanted them all to be pretty. We took those that didn't work, cleaned them up, ran them back through. So we shipped them to the customer who had an automated system. Well, what he got was two kinds of tips. The ones we'd reworked melted about 60 degrees higher than the original alloy because they'd been run through twice. And he caught that. So we were trying to make it pretty, but yeah, we're thinking about 30 degrees, and it's the alloy is. I think the big question there is that unless you get somebody extremely precise with a really good system, I don't think anybody really knows what their brazing temperature is. The temple sticks really help. I did get called in on an operation where it's a saw body. It's a saw, and the steel's breaking off in chunks of 4 or 5 tips each, and they were getting it way too hot. And I went back and looked, and they were showing me the automatic brazers that are programmed, and there's a curve on the screen, and it shows how closely that the brazing process is following the curve, and they're real proud of having real-time sensor control. And I looked at it, and it was bright orange. And I said, when was the last time the unit was calibrated? And the guy says, hell, I don't know. I don't know if we ever calibrated it. So they had beautiful sensing equipment, but they never calibrated the unit. So, and then you saw in the video where the braze alloy, in our world, once again, braze alloy will suck a saw tip into the notch. So that's what it should do, is it should suck it in, and then it leaves a couple of thousandths in there and makes a real nice joint. And where a good experienced brazier is having trouble, will tend to overheat the part, and they'll tend to shove the two parts together. In my case, the tips into the notch. And that's because they want to do a good job, and the only two things they have under their control are temperature and pressure, so they make sure they use enough of each.
I got a quick question.
Sure.
How do you get a better cosmetic joint if you're getting some overflow out of a carbide joint?
A lot of times with saw blades, what they'll do is they'll get the overflow out of it, and then they'll sandblast them to get rid of the extra stuff. There's also some braze. Do you guys sell braze stop?
Yes.
Yeah, some braze stop maybe. We like to see the overflow out of it. We really like to see a little bit of a fillet, a little bit of a sunken fillet coming out of the thing. And Black & Decker, once again, some research we did with them, they think a little bit of fillet on the edge adds about 30-40% to the strength in a saw blade anyway. So we don't, I guess we really don't worry very much about a pretty joint. If your surface preparation is really good, really consistent, and your heating is really good, really consistent, then you'll get a nice joint out of it. SS White dental burrs. I think they've got some pictures online. We did some analysis for them on that, and what they were doing with the dental burrs was, see, they're taking your lead.
Yeah, I was going to say, you're giving
this
leads
kid's
on
writing
these
it
guys.
down.
I forgot my pen last time, I'm sorry.
SS White dental burrs had the same thing. They were using too much force and pushing the braze all the way out. But it ought to flow out pretty.
You mentioned something that's pretty good, though. We talk about fillets on these braze joints, and most of our customers, where they just have a contact braze, and it's going to be tensile strength braze joints. On a cutting tool and that wear surface, it's a little bit different design or engineering because you have an impact zone. And I think what DML and all these other guys are talking about with that little bit of fillet is to use as a shock absorber to handle some of that impact. And I didn't know whether that's what you kind of picked up on that, or...
Yeah, part of it's a shock absorber. Part of it is that saws never cut straight. Part of it is that you get an exposure from the material coming into the joint that wants to work the tip back and forth. I just gave him another lead. We tried to get him to call. So
Okay.
if he's gonna work it,
These guys might keep you around just to say, okay, give us the top 50 guys off the top of your head. So.
Thanks a lot.
Oh, Sarah Tiz is putting in some automatic pre-tinning equipment that are going to use ribbon. So.
Now that was one of your customers.
Yeah, it was one of my customers, so they went in competition with me. I have a long history of customers going in competition with me, so we're a little less open about some of the stuff we do. And as we got into it, our big problem is automated brazing systems for saws are getting much better and much less expensive. And we spent, when we weren't selling, those years we were under contract and couldn't do anything, but we couldn't sell braze alloy because we couldn't compete. I kept talking about this great supplier I had, and now you guys are selling directly, so that's okay. We're finding them here and there. But yeah, we have been, and if you need it, we'd be happy to give you a reference. Talk about Prince and Izant, quality, delivery, how attractive the staff is. I guess that's it for me.
Thanks, Tom.
Tom,
Thank
that
you.
was great. Again,
Yeah,
thank you.
appreciate it.
Thank you very much.